Okay, I think that let's start. First of all, thank you for being here on a Saturday. I know it's a challenge for everybody to attend sessions for working days, so really appreciate that we have 34 people here in this session. My topic is about partitioning for beginners. The reason why it's for beginners is that I see in the field so often that with partitioning, lots of problems can be solved, but developers, due to the fact that it was formerly an enterprise feature, do not have it on a focus. And when I talk with developers about partitioning, I quite often see a question mark in their face and they, what? What shall I use? Partitioning? I have an OLTP system, so for what reason do I need partitioning? And here comes an overview of it, and I will hopefully show you lots of demos where you can see how partitioning can help you with your daily work as a developer. Just for you, if you want to download the session scripts and the slide deck, here is the link to it, to the scripts and the slide deck. I'm using my demo database, which I'm using for all my sessions. It's called ERP Demo. This is a not so small database because I don't like working with demo data with just only 10,000 rows. That's way too less. If you would to if you were to put some pressure on your database, on your demo databases, just use SQL Query Stress from Adam Mechanic. I absolutely love this tool and can strongly recommend to you to use this. Instead of Perfman, I'm normally using now the Windows Admin Center. It's free, and the good thing is that you can prepare your counters with JSON files, load them up, and then you can start with the demos. Only a few words about me. Forget about the commercial on the left side. The only important thing for you to know is my email address. So whenever you have questions concerning the database engine, anything about the database engine, just drop me an email, and I promise you to answer your question by email then. One word for a private project I'm actually loving to work on. It's called SQL Challenges DE. What is it? What you can do is I want to publish at least once a month a typical challenge what I was facing with customers, and you have then the opportunity to work as a consultant and solve it by yourself. If you're interested in actually 5 challenges are online, the next will come next week. So this is our agenda. First of all, to understand why you should use partitioning in your daily scenario, I want to talk with you about data storage internals. This is something what we need to understand before it comes to partitioning. And then I show you the benefits of partitioning or explain the benefits of partitioning. And after this, slides are gone. We just only go into demos. So I want to show you the components of partitioning, how to implement them, how to use them. And if we find the time, I want to show you the maintenance, what benefits of partitioning you have when it comes to big databases. It's called the maintenance for partitioning. First of all, a few things about the data storage internals which need to be understood. We all know that a database or a table is, for us, when we look from outside, only just an object which has data. But what SQL Server will do internally is whether you have a heap, a clustered index, or you have an index, all these 3 components are simple tables. And a table will always have at least one partition. So whenever you create a table, you automatically have partition in your table, but default just only one partition. What we will do then is we extend it, so we separate the table into different partitions. Every single partition can have 3 different, let's say, data storage techniques. We are talking about in-row data. This is what you all know. The in-row data means that a record will fit absolutely onto one data page. If it comes to bigger data, unfortunately, I see it very often. Also in OLTP systems, it's so-called out-of-row data. Out-of-row data does mean that the record will extend its maximum size of 8060 bytes, and then SQL Server has to put data from the row outside of the data page. And last but not least, we all know this stuff, log data. Log data are typically var binary max, and varchar max or varchar max data, which can have a maximum of 2 GB of data. But notice that these three types of data storage are presented in every single partition. It's a partition component. What is partitioning? Well, data of partition tables and indexes are divided into units. A unit can be spread across more than one file group in a database. That is the really, really cool thing about partitioning. The data in SQL Server are only partitioned horizontally, so that groups of rows are mapped into individual partitions. And here comes one point, but what is clear, all partitions of a single index or of a table must reside in the same database. You cannot use sharding for partitioning. I wish I could, but it's not logically possible. The table or index is treated as a single logical unit. And that is the cool thing about partitioning. So under the hood, there might be partitioning, but the application do not see this. And this is for me one of the most annoying things when I talk to developers from vendors saying, hey, why don't you use partitioning? And they say, no, we don't support it. We do not know whether our application is breaking. And then I think by myself, gosh, people, you know that you only see this one single table object. And Kocher formula does mean that the logical representation of an object must be completely independent from the physical. And this is how partitioning is working. Why people are not so often using partitioning is what I told you a few minutes before, is that partitioning was way back up to SQL 2014, an enterprise feature. And from the field, the experience from the field is that not so many customers are using enterprise edition. But with SQL 2016, Service Pack 1, there was a game change coming into SQL Server when Microsoft decided lots of functionality from the developer perspective move over into standard edition from enterprise edition. So partitioning is just only one of the features which have been available since SQL 2016 in standard edition. How does partitioning work? Well, what you see here is my demo table. It's called DBO orders. I have 30 million rows in it. And what you can see here is we have an order key, we have an order date, the customer key, and additional other attributes. The interesting thing is the second column, the O order date. And you see here that we are having orders for multiple years. And what we do when it comes to partitioning is that we put, for example, every single year in a different partition. But please notice, the most important is the application does not know about this implementation. The application only sees the orders table, nothing else. And the next thing, the next part is a very important part, how you distribute the logical implementation into a physical design. So what we have in SQL Server is the division between the logical and the physical part by a so-called file group. A file group is nothing else but a container. So this is the logical part, but behind we are creating our physical implementation. By default, when you create a new database, you just only have one database file, and that's it. But I think that most of you know how you can scale the workloads in your databases when it comes to contention on system objects, for example. You all know about TempDB. And what is the key factor of having a good TempDB? We are having multiple database files. And this is what you can do in every database, not only 10TB. So when it comes to partitioning in an OLTP system, this solution here with one single file group and then multiple database files underneath, this can really help to spread or to improve the workload in an OLTP system. But I come later on to this. When it comes to a data warehouse, we are changing the methodology a little bit. What we do is in data warehouses, because we want to have a focus more on maintenance than on improvements, is that we remove the structure from one single file group and put them on different file groups. When you see this solution here, you can clearly see that now management of the database, especially when it comes to a big database, the biggest database of one of my customers is around 260 terabytes. And they have an SLA. The business say we have to have at least the last 3 years within 15 minutes back online. When it comes to 200 terabytes, think about the time it takes to restore it when it's just only one single file. What you can do is that you can restore just only the latest 3, for example, here 2016, 15, 14. And when this one is online, the people can work. And then afterwards, you can restore the other ones. What are the benefits or the drawbacks? Because not everything is shiny with partitioning. I love partitioning. I work permanently with partitioning, but there are a few things we need to consider. First of all, the benefits of partitioning is that we have subsets of data which can be transferred or accessed quickly and efficiently while maintaining the integrity of data. For example, when we load data into an OLTP or OLAP system, maintenance operations can be performed on one or more partitions very quickly because we are not dealing with the whole table, but only with a small portion of the data. And here comes the third point, which is, I would say, there is always a big debate going on for this. Sometimes I read in LinkedIn about, yay, use partitioning and you can speed up your queries. No, definitely no. I would say 99.9% it is not about performance tuning. It is only about management. But query performance may be approved, but only on a very, very small and dedicated situations when it comes to so-called partition elimination. What does this mean? When you think about a big table, and let's say, and this is the key point, let's say you don't have an index on the order date and you're looking for all orders from 2011, well, then SQL Server need to scan the whole table from the very, very first order to the last order. But when you have your table partitioned, then SQL Server detects, oh, 2011 is just only in one single partition. I only scan this single partition. And what I show you is that the performance can massively degrade when you're using partitioning. The drawbacks or benefits, partition elimination. That's what I wanted that's what I talked about previously. It requires, if you want to use partition elimination, that you always using the partition key to make SQL Server aware, hey, I just only need to scan one single partition. There are a few drawbacks. Queries against partition table will run slowly when it comes to aggregation, and this is what I want to demo you. If the partition key is not a predicate for your non-aligned, for your index, then it will suffer from full scan operations. Index will be created as a aligned index by default, can lead to problems. Non-aligned indexes, if you're using that, I explained both later on to you, non-aligned indexes will make your plan to have optimized maintenance for big databases a joke, because in the moment you have non-aligned indexes, you cannot switch in, switch out, or merge or split. So when it's coming to partitions, or you are a developer and you're sitting there and say, hey, Uwe told me something about the cool feature partitioning. Where do I have to start? Well, that's very simple. We just only have 3 different components. The components of partitionings or partition is in the very first place, the partition function. A partition function must be created, and the partition function is, let's think about this like someone who is telling you, for example, you want to go to a football game or a soccer game in Germany, and then you have your ticket and ask someone, hey, this is my place, where do I have to go to? And then he directs you to your seat. And this is exactly the way how partition functions are working. The partition function maps the rows of a partition table into partitions. You get a partition number where your seat is. When you create a partition function, you name it and you define the data type of the incoming values. And afterwards, you define different values, right or left, come later on, for the partition value. For example, here we have the number 1, 10, and 100. By the way, very stupid, but simple. And now look to what's going on here. We say range right for values. And what you see here is that we have not 3 partitions, but we have 4 partitions. Always one more than values what we have defined. So why is it this way? Think about this. The partition function here tells me, okay, watch for values from 1 to 9, from 10 to 99, and from 100 to whatever. But here comes the question. What happens if someone is entering a value which is lower than 1? So therefore, what we need to have is the, in this case, what do we do with values which are higher than 100? So what SQL Server then is doing, or what SQL Server needs to do, is we need to cover every possible value. So there can be values outside of this range from 1 to 100, and that is how the partitioning is covering this, the partition function. That is the reason why we have to have one more partition. So you see here, partition number 1 goes from the very, very smallest value, the negative value, to the max value 0. In the partition number 1, we put all the values from 1 to 9, and so on and so on. And what you see here is that now we can cover all possible values. If we define it as left range, then it looks a little bit different. See that the offsets have changed, yeah? From what is it? Forgetting the name, to 1. And you see here that was formerly the 0, and then we come to the max value 1. The left value, so the direction defines where you have to be stored. And these are called partition ranges. In our partition function, we can have range left or range right to specify whether the boundary, because the values define the boundaries, belong to their left or right partitions. Left range means that the actual boundary value belongs to its left partition. Range left just means it is the maximum value inside the partition. Everything goes to the left. Everything what is smaller or equal. Exactly the other direction is right. But in right, and you define it as a right range, it does mean that the defined boundary value is the smallest value inside your partition. Everything what is larger will go to the right side. So this is something how I can, because that was for me all the time when it comes to partitioning, the hardest way to learn. Oh, what is left? What is right? How does it behave? The rest is very simple. So again, range left, the defined boundary value is the maximum value inside the partition. Range right, the boundary value is the minimum value in your partition. Oh, for God's sake, some demos. Okay. Let's start with the partition function. So what I'm doing now is this. I go into my demo database and I make sure that I don't have this partition function. And here I create my partition function. You see range left. The 1 is the maximum value inside the partition. And now I asked the guys, hey, here are coming some values. The first one had the number -10, the number 1, the number 9, and so on and so on. And what I want to see now is what direction would the value go to? Or other words, in what partition will it go? So here we are to see the function. And what you see that is that the -10 is in partition number 1. And you see that the 1 is the maximum value. So this one is the boundary for this partition number 1. Everything what is larger or is greater than 1 goes into partition number 2. 10, number 2. And you see the boundary goes to 100. So when I look to 100, that the maximum value goes to 3. But we have values which are higher than this 1, and that goes into the partition number 4. This is how it's working. Now let's change it. I drop it. You see the range right. Please notice here, really, really interesting. This time I'm not using some stupid integers, something else like this. I'm using a date. I would say it's over 95% when you look into partitioning that any date column will be the partition key. I say at the range right, everything goes to the right, and the representative value is always the smallest one. So this is the reason why I'm starting with the first day of the month to define the boundaries. So I create this. And once again, let's check it. And action. So you see here, 2024, the 1st of January is the first one. But this one goes into partition number 2. Why? Well, the range right defines that everything from this boundary must go to the right side. So, but what happens if we have a date, in this case it's a date, which is smaller, which is before this value, therefore we must hold free the first partition. And this is how it's going. Yeah, you see here, this is the 24th of December and the 31st of December 2024. This will go then in the 13th partition. If we do it on the opposite, or if we make an error in the definition of our function, then it could lead to big trouble. See this. Now I define the range as left. What does this mean? It does mean that this value is the biggest value inside a partition. I think you all know what happens now. And now think about your application. When you want to ask, for example, give me all orders coming from 2024, well, SQL Server at this moment has to access 2 partitions. Because the 1st of January goes into the very first partition. And that means that you have to query the first and the second partition. You see this here. Yeah. So if you ask from every order from 2024, unfortunately, we must go into the partition number 1. The mistake here in this moment was we defined the wrong border, or the boundary, sorry, or the wrong range border. We kill it, you kill it, we grill it. If you want to have for a date really a range left for, to be honest, does not make sense to me. With a date, it is simple. But what about if you store hours, minutes, seconds, milliseconds, and so on? This will never, ever work perfectly. If you have time intervals in your date, please do not use range left. Always use range right. Here it is okay, but you see, when I want to use the range left, I start with the last date of the month. I run the query and stop. I didn't. So again, go. And now the partitions are pretty well aligned. So the 1st of, you see this here, it goes into 1, the 2nd, 18, 23 is now in the 3rd one, and so on and so on. We have now a well-aligned boundary. So there are some views or DMVs where you can see how your function is defined, or if what parameter the function gets. But this is just only for DMVs where you can check it. I skip this. We have more important, cool things. So this is the first thing you need to create. Create your partition function and always have in mind whether it's left boundaries or right. The next step is the logical implementation. Let's say if you think about a stadium, the function is is someone who will guide you, say, okay, you have to go to this block, you have to go to this block. With the partition schemes, we build the logical implementation of these blocks in the stadium. The partition schemes defining is already for data distribution. A partition scheme defines how data is distributed across multiple partitions within a table or index. This helps in organizing large data sets and for improved, not query performance, but manageability. The storage management, which comes underneath, allows us to map partitions to specific file groups, enabling efficient storage management. And what we can do is we can load balancing across different storage volumes. The partition schema is quite simple, but there is one important thing to understand here. When we create a partition function, first, we define the boundaries. And please note, you saw it in the demo before, we always must have at least one more partition schema in the schema, one more partition to store data which are out of the defined range. So the partition schema is responsible for the physical storage. And what we do then is this. You see that a value comes in, and then it was guided through a file group. It could be just only one, or in this scenario, it could be more. And it's the same here. When we do it with the right, it only shows where the data will go to. Here is an insert statement. It's a insert into table, the value ID number 1. And what SQL Server now is doing is this. It goes through the partition function and it defines where the data must be stored. You see that the value, we have a range right, goes everything to the right side, everything what is bigger or equal to 1 goes into partition number 2. And behind the partition ID number 2 is the file group waiting for the data to store in the database file. How do we go with this? First of all, we create a partition function. Step number 2, when you have created your partition function, you create your partition schema. What's quite interesting here in this special scenario is that we can make it very, very easy to say, well, yeah, I know I have different boundaries, but put them all in the primary file group. I was asked in a session about this and said, hey, why are people doing that? And I said, well, very simple. What the people were doing with this is they were using it when it comes to OLTP systems or very small databases. Note this, when we spread multiple database files, we can put the data into different database files. What happens here? What SQL Server is doing, we have one file group. The table gets partitioned into multiple partitions, 1, 2, 3, 4. And what you see here is, due to the fact that everything goes into the primary file group, we cannot decide whether it goes into file 1, 2, 3, or 4. If we do it in a different way, like this, instead of using one single file group, but pushing every single partition key and its ranges into a dedicated file group, it looks like this. So now at that moment, we have two perfectly optimized systems here. First is, due to the fact that we put them into different file groups, we add multiple files underneath, and then we know that every single boundary value will go into its dedicated database file. Here it is the same, but now the only difference is that I define the range left, and then we have the last file group as the one which will cover all values which are not part of the boundary values. Partition schemas. Let's walk through this. I go into my database, then make sure that old stuff is deleted, and here we are. Again, I create my partition function. Here we are. And then I create my partition schema. And I say here, please give me everything on the primary file group. The primary file group in this demo database just only have one file. Okay. Here is how you can create new tables on it on a partition schema. I think that most of you know that when you create a table, you can define on what file group they should reside. What I'm doing here is this. You only need one, but I want to demonstrate both scenarios. When you create your table and you add a primary key as a constraint, you can always, by the way, with every index, you can define on what file group this index, because primary key is nothing else but an index, should be stored. If you don't have this one, you only have a heap table, just give at the end of the table definition the schema, which you have created, and you add the partition key. Let's create this. You see here, by the way, the customer is a big int, and look to this, that could lead to problems. Let's see. I need the C part key. Sorry, here, this one. This is an integer value. If I want to try to the customer key, it will fail because the big int is a different data type than the predefined data type for the function. Okay, and action. Done. And now let's see how my table is being separated over the file groups. Over the partitions. We don't have any data in it. That's fine. But here you see what data will go into what partition. Everything which is goes to right, lower than, right. There's a mistake here in it, but I don't have data in it. So now I create a stored procedure, partition demo. Okay, so this is just only a very primitive stored procedure. What it do, let me explain to you what it's doing. I'm just pushing data into it, only a few data, but I have a modulo 200, which means that we have at least 200 different partition key values. So this is my stored procedure. One moment. And what I'm doing now is this. I'm starting admin center. Did I tell you that I love this feature? This is so cool. Instead of perfmon, I have here the possibility to predefine my counters, what I want to use. Get up, partitioning, Windows Admin Center, loading. So submit. Good. And we look into this. I have a few counters here, very simple counters, but I need to go a little bit into detail to understand the numbers, what you will see here. You know, we have 3 values, 3 partition boundary values, but we have 4 partitions. So what I'm doing here is this. I'm inserting now into the partition table n rows. And what I'm doing then is I'm evaluating how many rows do we have in each partition. This is here the query, what I'm doing. And then maybe it's new for a few of you. What you can do is when you use perfmon, you have 10 user counters. This is a cool thing. The user counters in perfmon can be updated by dbcc set instance. And for example, you have a stored procedure where you always want to see how long did it take and so on and so on. And these user counters will then be used here in perfmon. See that? So when my stored procedure now is running, it permanently will update the user counters and we can see how this will work. So go. I reset them to 0. So here we are. So you see they are all on 0. And now let's go. I insert now 10,000 rows into it. Takes a little bit, but what you now can see here is how the data gets distributed into my different partitions. Notice this. I have a single partition key from which can be 1, 2, 3, or 4. With the modulo function, I count for every 200 rows the rest of the division by 200. So that means if I have the first value divided by 200, the modulo is 1, 2, 3, 4, and so on. And what SQL Server then will do is will automatically put the data into the right partition. The partition key here for the demo is nonsense, absolutely nonsense. But what you see here is that SQL Server is pretty cool distributing the data over into the partitions. So I stop this, it's okay. Let's see how many rows we have inserted. You see, exactly the same query which I have here in the last statement in my stored procedure. I'm running this, and now we are getting the numbers of values what we have in our different partitions. Yeah. So that's where you can speed up your OLTP system when you generate these kind of, let's call it hash partition key. I'm hashing it, no, not really, but I'm generating a substitute partition key. I don't like it, but it's okay. So, and what you see now is when I run the query and say, hey, this partition key, what partition are you in? You get this list. Yeah? 1, 2, 3, 4 divided by 300, give me all these values separated into different partitions. The number 3 is one of the most because here we have 100. And then we go into partition number 4, blah, blah, up to 200. And the 200 then must be here the 0. Partition key 0 goes into partition number 1. Super. Now we combine all information and action. And here we can see these are the ranges what we define. Let's clear everything and be happy. Feel free to ask any question when it comes to this little bit complex demo, but no, not yet. So restrictions. This is always the same. When it comes to Microsoft technology, it's mostly the point that you say, well, you can have all these kind of cool features, but, and this big but that makes me a little bit annoying. However, partitioning is based on a single column only. It's called the partition key. We had very, very often the situation that we thought, oh my goodness, I would like to have partitioning by customer and order, as an example, stupid example, I know. But this is not working in SQL Server. If you want to have a partitioning by more than one single column, you must create a calculated column based on the columns you want, and then you can create a partition key on it. It's possible to use a computed column. All data types that are valid for use as index columns can be used for partitioning. Timestamp cannot be used, end text. Okay, whoever used this, I know a few customers. Image, XML, max attribute, they cannot be used. Recommendations. It's important to select a partition column that is used as a filter for queries. Otherwise, you will really get into big trouble. If you don't use your partition key in your queries, then you will have a problem, because then SQL Server has a bigger overhead to start the query by managing the partitions. Implementation. So now we come to the fun part. Now it's becoming interesting. Let's implement this step by step. What I'm doing here with my database is, because I want to speed up my system, is this. The good thing, you remember the slide where I have showed you the different file groups and there was just only one single file edit. It could be, and that I had one customer where we dealt with this, that, for example, there is one hotspot in the system. And what we did then is to spread the workload a little bit better on this partition. We added only to this single partition multiple database files. And this is a technique what I mostly prefer when it comes to partitioning solutions. What will I do? This is just only for improving the rest of the code. I go through my table orders. This orders table had 30 million rows. And here you can see the different years I'm storing data in. It's from 2010 to 2023. So what I need is, I need a partition function which is covering every single year. So from 2010 up to 2023. I'm doing it in a very simple, easy way. We start with the file groups and the physical implementation. Have a look to the code. I hope that you all can understand what I'm doing here. I'm going with the not with the cursor, but with the loop through the different years. I'm looking here for my instance data path, and then I say, this is my min year, this is my max year, perfectly, and then I create a statement here. I just say alter database, add a new file group, and this had the name, orders, and the actual year, what is in the loop. And afterwards, I create a different database file, and I loop back to the next year. This is what I'm doing now. And action. That goes very quick. Here is the statement, what it's doing. And you see that for every single year, I get a different file group and I get a different database file. Let's check it. And when I check it, I say, wow, finished. Yeah, that's it. So this is the physical implementation with the logical layer or with the logical connector to the database. There is nothing partitioned here, but it's only a physical and a logical abstraction of my, in the next step, created table, the distribution of data. However, when this is finished, in the next step, we go to the partition function. With the partition function, I do exactly the same as with the file groups. I go through my orders and collecting every single possible year. And then when we look into this, we can see here for the year 2010, we found the 1st of January up to the end of the year, and so on and so on. Now comes the most important question. Is it a left or is it a right boundary? So in this case here, I'm using a right one. That means I'm starting with the smallest value. Every partition starts with the 1st of January of the covered year. So here I'm selecting my min and my max so that I know where to start and when to finish. And what I'm doing here is I don't like to do it hard-coded. Otherwise, you would see here lots of dates. 1st of January 2010, 1st of January 2011, and so on. What I'm doing is I'm creating only the very, very first boundary. And with the split range function, I can add one more. And I do it for every single year. And done. And this is the result. You see, here's my range. This is my boundary. The parameter ID is only the data type. But here you see from the 1st of January 2010 onward to the end of the year, we go into this one. And then we go into this one and this one and this one. That's it. Now comes the last step. And the last step, unfortunately, and this is something where I'm not so really happy about, I didn't find a possibility to do it, let's say, automatically. I needed to do it hard-coded here. And you can see what I'm doing is very primitive. You know, I have created all my file groups. So let me remove this one first, X. So I drop my partition schema, and then I create this. And it will work. Oops. What? Orders 24. Fun fact, one single moment. Okay. No problem. It's okay. And action. Yeah. Okay. Need to check my code. So now I have up to orders 2023. All my file groups bound to the schema, and here we are. Yeah, you see in which one, there is one more mistake, but it's okay. So you see, these are the file groups and where the data will go to. And that's it. So now infrastructure is ready. And now we must see how we can use this. The environment is pretty simple. This is what I did. I have my orders table. I created a function, order date, and I have a schema, created my file groups with my database files, and done. Yeah. Now we implement them. Now we go into the data. Let's see how we can distribute the data. The infrastructure is ready. So what I'm now doing is I create a schema demo because I want to create a new table. And you know, as I said to you, when you create a new object, just only name the partition function, partition schema, sorry, to put or distribute the data on the different partitions. And these partitions go into the different file groups and into the different database files. Let's insert a few rows into it, just only for 2010. And let me show you how cool that works. I go into my disk. Come on, where is my SQL Server? No problem. I put them in. And action. So now the data gets into the, here you are, SQL Server. And look at this, TempDB is absolutely fine because that's a sorting going on. But what you see is here, we are just only writing into this one dedicated file. And here comes the good part. If others are working in the different partitions, super fast, because they don't get blocked so far. Here they get blocked, but there's one setting missing, but that's okay. So now when the data are in, we can now perfectly see how the data are distributed. You see that in the orders, in the second partition, we have 2.2 million rows, which consumes 300 megabytes of data. If you do this with a clustered index, it's exactly the same. The only thing what I do is I create my primary key, which is clustered by default, unfortunately, however, and then we do exactly the same. We put now 3 years in, go, and now see what's going on. Takes a little bit. So this is the sorting operation in TempDB, but then you see here with the data are coming. First is 2010, it's a serialized process, but then 2011, and the next is 2012 and up to 2013. Now, SQL Server normally is way faster receiving data in memory than pushing them into the table or into the database files. Here it's completely different because the data are coming very, very fast from the memory. They were pushing into the log manager is pushing the data into the database files, and this is working simultaneously. So that will definitely speed up your system. Insert the data. And now we have these 3. You see 1, 2, 3, 4 perfectly distributed into my schema. Action. So that's it. The challenge is always when you implement partitioning later on. The last project, it's only just a few weeks ago, that was really a big challenge, an absolutely challenge, because what they did was they were storing, 9 minutes to go only, they were storing log data in it. And the problem was that they couldn't delete, that the deletion were a nightmare because the pages have not been released. So now let's check this. Move the table on the primary file group. Yeah, the orders. That's the orders. So that is okay because orders is not. Let's check the orders. Bam. Go. So you see no partitioning, but the partitioning is implemented. So if you want to move an existing table into a partition, this can be a nightmare. Why? You cannot move a table after it has been created on the primary, the table itself, to a partition. The only way to do that is this one here. My table is a heap table. And let's say we want to hold it as a heap. We don't want to have a clustered index. Then the way is this. To move the table to the partition, there is just only one way, one. We have to create a clustered index because then the data get be written in a new table and the table gets replaced. Let's do this. Action. Takes a little bit because there are 30 million rows which need to be written, but you have the sorting, that's clear. And suddenly we will start with all partitions we are writing simultaneously. Let's have it a little bit time. The sorting is going on, and yay, here we are. You see, we are evenly distributing, writing the data to the storage. And this is only a poor little tiny laptop. Think about Zahn storage, where we have a way better throughput as in a laptop. This one has I think 400, 500 gigs per second. This is, but you see how perfectly Microsoft is distributing now the data into the physical implementation. So it's done. Was taking 23 seconds, and here are all my data now in the index. Super. And the next step, if I want to leave it as a heap, would be drop the index, the clustered index, bam. But the good thing is that SQL Server will leave the table on the partition. What I don't show here is when it's coming to column store indexes. Honestly, my personal opinion about this is an absolutely mess how Microsoft has implemented it. I just only want to explain how it works. First of all, you must create a a clustered index on the next partition key. In my example, the order date. Drop it. And then the data are sorted by this one. And the next thing then is that you create your column store index on it. Horrible. I did it in a POC. We immediately stopped it and say, no, this is not the right way to deal with this. So I clean the environment, and then I want, because this is important for me, that you really, really understand that partitioning, 5 minutes to go, then just one query. Here we come. I go into my, stop. I need to prepare it. Sorry. So I go into my database. Okay. I don't have my, so they are not implemented. 1 second. Primary key. Where are you? Wenn es mal schnell gehen sollte. An existing table. That was so stupid from me. Go into ERP demo. Give me another 20 seconds here. So put the order key. So, and let it run. Because we'll finish later. We will finish. So what I'm doing is this one. You're going to see that my table, 30 million rows, are now completely, when this one is finished, partitioned. And then afterwards, I want to run a query about this. So it's done. Here is my query. So normally I would ask you, will that work? Is partitioning great? But I can shorten it here. With this kind of query, you will not have any benefits, because what I'm doing here is just only going over the whole table. I do not have a predicate in it. And if I don't have a predicate on it, we don't have any benefits of it. So here comes the next thing. So let me show you the execution plan. And please have a look to this one here. 1 second. You're going to see here, one moment, here. Look to the actual partition count. It's 15. So that does mean that SQL Server needed to go through all of the partitions. Only in the moment when I use the partition key, then we have a small benefit, because now SQL Server is saying, yes, it is partitioned, and look to the actual partition count. It's just only 1. And yeah, it is in old times, let's say 10 years before, it was a big benefit. But look to this query here, and you will see, oh my goodness, that cannot work, because I'm just querying, give me all my orders from customer number 10. The customer is not partitioned. So you see, it's taking a while, and we need to go through all these partitions. And this is exactly what I mean when it comes to, no, partitioning is not a benefit. And now let's show you, as the last example, the worst thing. Aggregations. And this is a true story from a customer for me. Let me go through this. The customer is filling an online analytic data warehouse every 5 minutes. What they needed to know for this is what was the last ID they've imported. So this is what I'm doing here. I say, give me the last order key and action. We can play Jeopardy. I can dance. We can do it. Go for a coffee. No problem. Or maybe you want to, oh, it's done. Wow, that was incredible fast, right? We say, what the heck is going on here? What we have is, it's walking through all 15 partitions. It doesn't look really cool. So what we do then is, let's try it with this one. Just only one partition. Oops. And what I would think is that SQL Server now will go immediately to the last order. No, it's doing a full scan. Look to the number of rows we've read. It might be that there is not a an index on this order key. However, let's run it this way. One moment, zack. And it was very quick. And now there is an interesting phenomenon. I used the $partition function from Microsoft, taking my query, my partition function, hand over the order date and name it with a partition ID. What is the difference between this query and this query? Very, very simple. Range scan equal operator. The partition elimination works always first, always. So what SQL Server here knows, oh, I only have to look into partition number 12. And inside the order key is ordered. And what we get now is we start the scan. Do not think that the scan is expensive. It starts from backward and stops after the very first record. We just only get one record. Now, these information, let's put it together into speeding up the query. And when you see this, you would say, oh my goodness, I only want to have the last number. Well, what we first of all need to know is give me for every single partition the last number. That was really quick. Here it is. Yeah, we go with the scan, but always with the top. And the only thing what we then need to do is I want to have from these numbers here the last value. And this is how we changed it. Yeah, we say, give me the last number, bam, and here we are. And I think, wow, we are nearby, just in time. We are finished, and I hope you enjoyed what you have seen with partitioning. I know we were a little bit fast, but you have the opportunity to download the scripts, play around with this, and I hope that you will have as much joy with partitioning as I have. Thank you very much.